Hey everyone. Today's lesson is an introduction to the Math of War series, the Math of War. We will talk briefly about the main goal for the Math of War series and then also a little bit about the sources of inspiration for it. So diving right in. The goal of the Math of War series is to provide you, readers and viewers, with a set of decision-making tools. Now these tools, when in a relevant context, which is to say when you are in a situation where the tool can be applied as it was intended to be applied, these tools essentially serve as mental machines that will make the process of reaching a decision easier and faster than it would have been in the absence of the machine. Now, since the machines that we're going to be talking about are essentially mathematical in nature, they're mathematical functions, principles, and dynamics, they will produce the same output for any given input each time you use the machine. So they really do function like a machine. They behave in exactly the same way every time they're used. Now, as with any other tool, the tool can't do the entire job for you. And in fact, it can't find what job you need to do. It can't identify the problem you want to solve. It can't just go out there in the world and look for problems for you. Nor can it be used in all contexts. So once you find an issue that you're facing, any given machine that we talk about may or may not be applicable to that particular context. However, once you do find the right context, so when you really do put a hammer with a job that is best handled with a hammer, and when you really do put a screwdriver with a job that requires a screwdriver, when you do find that right context, the machines we discuss will be able to handle part of the decision-making process for you so that you can free up your mental resources and your time to be focused on whatever still remains to be determined. Now, the general sources of the Math of War series, in terms of the inspiration, if you will, they're not necessarily sources. I won't be drawing upon these texts directly for the material, but at least at the kind of inspirational level, the classic texts in this field that many of you will have already read or become familiar with are the texts that I also was inspired by. So, for instance, Sun Tzu's Art of War, Machiavelli's The Prince, Clausewitz on War, and Alfred Thayer Mahan's The Influence of Seapower on History. All of those texts have been read for centuries and have benefited people in a wide variety of contexts. And I feel like the endeavor that they were pursuing in their given time is one that is worth pursuing today. And I think that the field can still be expanded greatly today and improved. So we have this foundation that they have laid through the years and centuries. And I think that we can improve that foundation and continue to find additional ways in which this whole endeavor can benefit not only in a very specific war and combat and exertion of power context, but in other contexts like law and litigation and the business world. However, you'll notice that the goal and approach for this series, as we've talked about already to a degree, is different to a degree from those preceding texts. While those texts sometimes provide warnings and admonitions that can help you in the decision-making process, these observations that they tend to focus on tend to be psychological or organizational or even sociological in nature. Thus, for instance, Sun Tzu might point out the importance of knowing yourself or the importance of knowing your opponent before going into a campaign or a war or a particular battle. Same with Mahan. Mahan might point out the importance of leadership or bravery in a battle. And while these are certainly crucial ideas that have a great bearing on the outcome of any given conflict, they are not essentially mathematical in nature, and as a result are not easily reducible to a machine that can function to provide results that are accurate and reliable in the exact same way time after time. So they don't really draw out machine-like functions in these pre-existing texts. And this very mechanistic type tool that we're looking for is the kind of crux of the Math of War series and the endeavor that we're pursuing currently. Now, note that the standard of 100% reliability and replicability is a very high standard to meet, and therefore the set of principles that we'll be discussing is relatively small. However, once you have mastered this set of mental machines, you will be equipped to make better decisions and to make decisions in a more efficient and consistent way than you could have in the absence of these machines. And that consistency and efficiency is itself a big benefit, so that your decision-making process, not only because you can get to the right decision, but also because you can share, for instance, the ways in which you got to the decision. So the process is kind of externally verifiable by other people. You're not usually going to be making a war or combat or exertion of power or conflict type decision in a vacuum, just all by yourself. You could be a lone soldier who's in a sniper context, for instance. But for the most part, you're going to be making decisions within a network of other people. And so that kind of shareability of the ways in which you got to your decision is a benefit of this kind of approach. So since they are essentially mathematical in nature, and since they are replicable in this way, they also avoid any human subjectivity. And as a result, you can know that even in the chaos and urgency of a true combat or battle or war situation where things are happening in very rapid succession and you're just having to make decisions in real time, these machines can keep on doing their job, the job they were intended to do, whether or not any particular human being keeps a cool head. Now, cool-headedness is, of course, something that writers like the authorities I've just mentioned would put, properly so, a great deal of emphasis on when you're dealing with human beings. However, can you count on having cool-headed people in your environment? Can you count on yourself always being completely unflappable? Well, hopefully, but possibly not. But these machines, these mental machines, they are unflappable because they're simply mathematical. And since you can give them one little input and produce an output that they will do in exactly the same way, whether you're calm or not, that is a very valuable feature. Now, one additional great advantage of the Math of War series is that you don't have to take my word for it. You don't have to take some famous general's word for it. So you don't have to listen to Napoleon or read Caesar's Wars on Gaul or listen to Alexander the Great or Hannibal or whoever it may be that is your favorite battlefield commander. You don't have to listen to them in order to understand the Math of War principles we're going to discuss. You don't have to have any combat. You don't have to have any war planning experience. You do not need to be able to ride a horse or swing a sword or sail a ship or fire a gun or have any other fighting skill in order to understand and use these tools or these simple mental machines. In fact, you can prove these principles and even recreate them for yourself with just basic math. So addition, subtraction, multiplication, division, and some straightforward geometry. Those simple mathematical concepts that you've already got installed should be enough for you yourself to rederive these principles on the back of an envelope if you have to. Another great advantage of the Math of War series and approach is that you can practice the use of these machines and gain firsthand experience with their validity and their power in a wide variety of readily available contexts that you encounter pretty much every day. So, for instance, traditional board games, chess, checkers, that kind of thing. In fact, one of the principles we're going to discuss is something that I learned at a very early age through a traditional board game. You can also gain experience with these machines through card games like Myths and Magicry, for instance, or role-playing games like Dungeons and Dragons. You can also put them into action with video game simulations, such as a first-person real-time shooter game like Borderlands. I'm wearing my Borderlands sweatshirt in honor of the occasion here. And you can use a first-person shooter like that, or a turn-based strategy game like Civilization. But whatever the case, whichever context is the one that you prefer to work in, you can learn to use these tools. And in particular, part of what you're looking for is learning the kind of when and where and how to apply these tools. And you can learn that through these various games and simulations. Now, all that being said, I'm not going to make you have to learn them that way. I'm going to explain these machines as best I can and set forth some examples of how they might play out in a given context. And along the way, I'll also try to extract some ramifications of the machine and how, when it gives us a particular output, what does that mean? How does that impact the decision-making process of, for instance, your opponent? If you make a decision based on your machine's output in part, then how is your opponent going to respond, who may also be aware of, at least at the intuitive level, of the function of the math involved here? So I'll try to draw out at least some of those implications, although implications, that's a good new word, combining implication and ramification. But I'll try to draw out implications along the way, but that's not our main mission here. Okay, one more advantage of the math of war approach is that these mental machines, these tools that we're going to be discovering, are applicable at many different levels of scope. So, for instance, because they are reliable in a mathematical kind of way, and because they are simple, meaning that you can just put in an input and get an output in very short order, they are the kinds of principles that can be used in a real-time combat situation involving just a handful of individual fighters, like in a house-to-house fighting context, very up close. At the same time, they can also be used at a very high level of abstraction. So, for instance, they can be used in the preparation of a campaign that's supposed to take place years in the future and involve thousands of participants. These machines can also help at that level. Even at the highest level of a nation's policy with respect to international politics and diplomacy and design of a military itself, these machines can serve a powerful role, not only in the increasing of the efficiency and the reliability of that decision making, but also in the shareability of the decision making process, so that you can share your work with your colleagues who are likely to also be involved in that decision-making process. So for all those reasons, the tools are widely applicable at a number of different levels of scope and abstraction. So with all that being said, I hope that you have been at least partly intrigued to dive into this, what I consider to be an extremely fun undertaking, which is the undertaking of the math of war. And until our first lesson, I will say bye for now and look forward to seeing you then.